So in this video, we're going to talk about how to solve logarithmic equations. So you can use the properties of logarithms to solve logarithmic equations. So when you're solving, remember to check for extraneous solutions because the domain of a logarithmic function does not include all real numbers. Remember that you can only take logarithms of numbers that are greater than 0. So first let's talk about this property, which is called the equality property of logarithms. So it tells us that if we have two logs with the same base that are equal to each other, so if log base b of x equals log base b of y, that means that x equals y. So that helps us solve equations like this. So say we have the log base 5 of 4x minus 7 equals log base 5 of x plus 5. Okay, so notice that we have logs with the same base, so we're just going to set 4x minus 7 equal to x plus 5. And now all we need to do is solve for x. So to solve for x, I'm going to start off by moving all my variables to one side. So I'm going to subtract x from both sides. Remember when I'm subtracting x, that is a 1x. So 4x minus 1x is going to be 3x. And then I have minus 7 equals 5. Now to solve for x, I'm going to go ahead and add 7 to both sides. And when I do that, I end up with 3x equals 5 plus 7, which is 12. And I'm going to divide both sides by 3. So I have x equals 4. So you always want to make sure and plug back into your original equation and make sure that you don't have an extraneous solution. So I don't want a situation where I'm trying to take like the log of a negative number. So I'm just going to plug this in to be sure. So I have 4 times 4 minus 7 equals the log base 5 of 4 plus 5. So I have the log base 5 of 4 times 4, which is 16. 16 minus 7 is 9. And this tells me the log base 5 of 9 equals the log base 5 of 4 plus 5, which is 9. So that works out. So now you can pause the video and try this example on your own. So notice that we have the natural log on either side, so same base. So we can set 3x minus 1 equal to 2x plus 4 and solve. So we're going to subtract 2x from both sides. We get x minus 1 equals 4. Then add 1 to both sides and you get x equals 5. If we plug it back in, it does work okay. And so that is our solution. So we can also use this property, right? Our property where we convert logarithms to exponents. We can use that to solve logarithmic equations, right? Remember, we just need to draw in the arrows. And this will turn into b to the x equals y. So what if we're trying to solve this equation? The log base 4 of 5x minus 1 equals 3. Okay, so we have a logarithm that is equal to a whole number. Okay, notice over here we have a whole number. We do not have a logarithm. So that is when we know to use this property. So I'm going to use my exponential form to rewrite this equation. So I get 4 to the third equals 5x minus 1. Okay, 4 to the third is 64. Remember, you can do that on your calculator. That is 4 caret 3. Which is also 4 times 4 times 4. So you'll get 64, and that equals 5x minus 1. So now all I need to do is solve this equation for x. So I'm going to add 1 to both sides. And when I do that, I get 64 plus 1, which is 65, and that equals 5x. Now I need to divide both sides by 5. And 65 divided by 5 is 13, so I have 13 equals x. And that is my solution. So if I plug back into my log just to be sure, I get the log base 4 of 5 times 13 minus 1 equals 3. So that is the log base 4. 5 times 13 is 65. So I have 65 minus 1 equals 3. So that tells me that the log base 4 of 64 equals 3. If I check this by rewriting an exponential form, that does work out okay. I get 4 to the third equals 64. So now you can pause the video and try this equation on your own. So remember, we're going to rewrite an exponential form because right here we have a whole number. So that is what we're going to do. So we have 2 to the 5th equals 6x plus 2. 2 to the 5th is 32. So we can solve by subtracting 2 from both sides, which gives us 30 equals 6x. Then divide both sides by 6 and you get 5 equals x. If we plug 5 back in, we get the log base 2 of 32 equals 5, which does work because 2 to the 5th equals 32. So another situation we can have is where we have to use one of these properties when we have our product property, quotient property, or power property. we can use these to rewrite expressions and then use that to solve an equation. So these problems kind of look like this, right? So you see we have more than one log on the left side, and then we have one log on the right side. So, thinking ahead, if I had just one log on either side, I could solve this equation using the equality property, right? So I'm going to try to condense what I have on the left into one expression. And I can do that because I have the same base on the left. So I'm going to use this product property. I'm going to rewrite this as the log base 2 of 4 times 3x minus 1. Okay, and that equals the log base 2 of 12 plus 4x. So on the left side, I'm going to go ahead and distribute because I'm multiplying the 4. So I have the log base 2 of 4 times 3x, which is 12x, minus 4 times 1, which is 4. And that equals the log base 2 of 12 plus 4x. So now you can see I have just one expression on either side. So I can go ahead and set those two equal to each other. So I have 12x minus 4 equals 12 plus 4x. So now since I have a variable on both sides, I'm going to go ahead and collect all my x terms together. So I'm going to subtract 4x from both sides. And I have 12 minus 4x, so that's 8x minus 4 equals 12. And now we're going to add 4 to both sides. And when we do that, we get 8x equals 16. Now to solve for x, I'm going to go ahead and divide both sides by 8. And when I do that, I get x equals 2. Remember, you always want to check your solutions and make sure that they work in your original problem. So I have the log base 2 of 4 plus the log base 2 of 3 times 2 minus 1 equals the log base 2 of 12 plus 4 times 2. So now I have the log base 2 of 4 plus the log base 2. Let's see, 3 times 2 is 6. 6 minus 1 is 5. And that equals the log base 2 of, let's see, 12 plus 4 times 2. 4 times 2 is 8. 12 plus 8 is 20. If I condense the left side using the product property, that tells me the log base 2 of 4 times 5 equals a log base 2 of 20. 4 times 5 is 20, so this is telling me the log base 2 of 20 equals a log base 2 of 20, which does work. Okay, so now let's try solving this equation. So notice once again, I have more than one log on the left side, and I have just one log on the right side. So I'm going to combine the left side using the quotient property since I'm subtracting. So this gives me the log base 3 of x over 2 equals the log base 3 of 2x minus 3. So now that I've condensed this into one expression on either side, I can say that x over 2 equals 2x minus 3. Okay, so since I have a fraction and I have some variables and I'm trying to solve, I'm going to make the right side a fraction also, and then I'm going to crisscross multiply. Okay, so on the left side, I have 2 times 2x minus 3, and then on the right side, I have x times 1. Okay, so I just have x over here. So on the left side, I'm going to go ahead and distribute 2. So I have 2 times 2x, which is 4x, minus 2 times 3, which is 6, and that equals x. So I'm going to gather all my variables on one side. I can do that by subtracting 4x from both sides. And when I do that, I get negative 6 equals, I have 1x minus 4x, which is negative 3x. I'm going to divide both sides by negative 3. So negative 6 divided by negative 3 is 2, so I have 2 equals x. Okay, so let's always make sure and check our solutions. So I have the log base 3 of 2 minus the log base 3 of 2 equals the log base 3 of 2 times 2 minus 3. So this tells me I have the log base 3. If I combine them using the properties, I have the log base 3 of 2 over 2 equals the log base 3 of 4 minus 3, which is 1, which tells me the log of 1 equals log of 1. Okay, another way to think about this, if you notice on the left side of the log base 3 of 2 minus the log base 3 of 2, which is 0, right? You could also think about it as 0 equals the log base 3 of 1, which does work, right? Because remember, we have that property that 3 to the 0 equals 1. So now you can go ahead and pause the video and try this example on your own. So in this one, you're going to want to use the product property to go ahead and combine the terms on the left side. So you'll get the natural log of 6 times x plus 2 equals the natural log of 24. Then if you distribute the 6, you get 6x plus 12. And so now that we have one expression on either side, we can say that 6x plus 12 equals 24. Then you solve by subtracting 12 from both sides and then dividing by 6, which gives you x equals 2. If you plug x equals 2 back into the original equation, you get the natural log of 4 plus the natural log of 6 equals the natural log of 24, which does work out. So I also want to show you how to solve this equation. In this one, we are going to simplify using the properties. But notice on the right side, we don't have a log, right? We just have a whole number. So what we're going to do is we're going to combine them using the product property. So we have the log base 2 of x times x minus 2. And then that is equal to 3. Okay, so I'm going to go ahead and distribute this x. So I have the log base 2 of x squared minus 2x equals 3. Remember, whenever we have a whole number on the right side, we're going to use that exponential form, right? So we're going to use not the equality property this time. We're going to use exponential form to solve. So we have 2 to the third equals x squared minus 2x. Okay, 2 to the third is 8, so we have 8 equals x squared minus 2x. Well, now we have a quadratic equation, right? Remember that quadratic equations, we need to write in the form ax squared plus bx plus c equals 0 in order to solve. So I'm going to subtract 8 from both sides so that I have my equation set equal to 0. So this gives me 0 equals x squared minus 2x minus 8. Okay, so remember, this is my value of a. This is my value of b, this is my value of c. Since I have a situation where a equals 1, I'm going to solve by factoring, because as you all know, that is my favorite way to solve quadratic equations. So I have c equals negative 8. Since 8 is negative, I'm going to need a positive and negative factor. I'm going to list out the factors of 8, so I have 1 and 8, 2 and 4. And then since b is negative, I'm going to make my bigger factor negative. Okay, so all these bigger factors negative. Well, 1 plus negative 8 is negative 7, so that's no good. 2 and negative 4 is negative 2, so that's going to be my perfect combination. So I'm going to rewrite this as 0 equals x plus 2 times x minus 4. And then all I need to do is now set each factor equal to 0 and solve for x. So when I do that, I have x plus 2 equals 0. If I subtract 2 from both sides, I'm going to end up with x equals negative 2. I have x plus 4 equals 0, so if I add 4 to both sides, I am going to end up with x equals 4. So now I need to go back and I need to check if these solutions work in my equation. So remember, my equation was the log base 2 of x plus the log base 2 of x minus 2 equals 3. Well, if I first plug in my x equals negative 2, I'm going to get the log base 2 of negative 2 plus the log base 2 of negative 2 minus 2 equals 3, which tells me I have the log base 2 of negative 2 plus the log base 2 of negative 4 equals 3. Well, this won't work because I can't take the log of a negative number. Okay, if you want, you can try it on your calculator. It'll give you an error message. So this is going to be an extraneous solution, so x equals negative 2 doesn't work. Now let's try my other solution. Let's try my x equals 4. And when I plug that in, I get the log base 2 of 4 plus the log base 2 of 4 minus 2 equals 3. So I have the log base 2 of 4 plus the log base 2 of 2 equals 3. If I combine these using the product property, I have the log base 2 of 8 equals 3. If I rewrite in exponential form, that is telling me that 2 to the third equals 8, which is true. So now you can pause the video and try this similar example on your own. So just like we did in the previous problem, we're going to combine the left side using the product property. So we get 3x squared minus 3x. So we can rewrite in exponential form. So we have 6 to the third equals 3x squared minus 3x. 6 to the third is 216. Since it's a quadratic, we're going to rewrite it in ax squared plus bx plus c equals 0 form. And so when we do that, notice that these three terms have a GCF. Okay, the GCF is equal to 3. So what I did is I factored out that 3. So remember, that means I put the 3 in front and then divide each term by 3. So I have 3 times x squared minus x minus 72. So what I can do now is divide both sides of the equation by 3, which gives me x squared minus x minus 72. I'm writing out the factors of negative 72 because that's c. And I'm going to make the bigger factor negative since b is equal to negative 1. The correct combination of factors is x plus 8 times x minus 9. So I have to check both my solutions, which are x equals 9 and x equals negative 8. When I check x equals 9, my solution's good. When I check x equals negative 8, I end up with the log base 6 of negative 24 and the log base 6 of negative 9. So since I can't take the log of a negative number, x equals negative 8 is my extraneous solution. So remember, you can use the properties of logarithms to simplify so that you can solve equations.